Hello and welcome to another tutorial of SystemVerilog in 5 minutes. Today we continue with class members attribute. Let's start with something light. This is a retro arcade game. There's a spaceship trying to avoid the incoming meteor. If it crashes, its life would be reduced until all lives are spent. Let's say we want to model the life management of the game. We can create a class called CLife. It contains a number, life. It is initialized to 3, and then there's a function called crash in which every time it is called, life will decrement. And if life decrements to 0, a message is printed to indicate game over. Here we create a module to use CLife. After we instantiate the class, we can call its function crash, and then we can display its life. There's something not right about this code. Do you know what it is? Stop the video to think about it if you want to. Well, the code is working fine, however there is a loophole. You can modify the member life as you wish. After you call crash, you can revert life back to 3. Even better, you can set life to a huge number. You can say it's a cheat capability, but if you wish for a fair game, you can change the attribute of the life by adding the keyword local. Then users can no longer access the variable. If you need to read the member value, you can create a function to get it, practically making the local member read-only. This is the concept of abstraction. In a class, there will be members which we do not want to expose to users, and then there are those made public to users. Abstraction is the concept where we hide the implementation complexity from users. Here's another example. This is a Fibonacci number generator. It has a function getNumber. Before we look into its implementation, let's see how it is being used. Basically, you call the getNumber function to get a Fibonacci number at a given position. There are many ways to implement the class. One simple way is to use an array. This array contains the first 20 Fibonacci numbers. The function simply returns an item from the array. The bad thing about this code is the array can be modified by users, and the array is incomplete. Users can also choose to use the array directly instead of using the getNumber function. Let's say in the future you found the algorithm to generate all Fibonacci numbers. You can improve the code and remove the redundant array. However, customers may complain about the class because the array that they were using is gone. So in one way, abstraction provides a flexibility to improve on existing code without breaking customer expectation. Now let's move to another concept. This is a dummy class, and there are multiple handles. How can you tell how many times the class is instantiated? Of course, this is too simple and you know there are 3 instances, but imagine the class is used by many files and you cannot find them all. One way is to use a counter. Every time the new function is called, the counter is incremented. The problem with that is the counter step can be easily forgotten. It would be much better if the counter exists in the class, and every time the new function is called, the counter is incremented automatically. If you move the counter into the class, this is how it looks like. Unfortunately, this code does not work because each of the instances has its own counter, so there are altogether 3 members count. After the handles are instantiated, each count is 1 respectively. Now if we use the keyword static, it makes the member count being shared by all the instances. There are 3 instances here and therefore 3 members I, but there is only 1 member count. Every time a handle is instantiated, the member count would increment. Then you can use any instance to access the member count. This is another example. The class has a constructor and it has a display message. Let's say you don't want to print the message all the time. You only want to print the message when you are in debug mode. You can introduce a static member debug, then you can control it like this. There is a mistake here. Do you know what it is? Well, CN0 has not been instantiated and therefore it cannot be used. To change the static member debug without using any class handle, you can use the class name with double colon. Imagine you have 2 classes, each has a static member count. These 2 members are not the same. If you instantiate the classes, here CNumber count only affects CN0 and CN1, and CString count only affects CS0, CS1 and CS2. One more syntax before we end this. This is a simple class example, everything works fine. However, there is a philosophical question. Can we change the argument name to ID? The answer is yes, we can. But if we do that, how do we differentiate between this ID and that ID? The answer is literally this. By using the keyword this ID refers to the class member ID, and this ID refers to the function argument ID. Today we've learned about the syntax local, static, and this. Next, we'll discuss about pointer behavior of a class.